and then NASA is going to activate and fly, and then Airware is going to activate and fly.
So you can see the flight plan on the Airware side has changed a little bit. They've kind of made the geofence a little narrower, and then on the NASA side you can see they've also kind of lined the two up side by side.
NASA's plan has been accepted. NASA_P8 is over on the manager display. You can see that happening.
And Airware is going ahead and submitting right now on the left-hand screen.
So hopefully we'll see 2 accepted flights on the manager display here in a minute.
So it's been submitted.
Awesome. So as many people have alluded to, Dave Voss was here yesterday. The system doesn't have to be that complex. The technology makes sense, right? I mean, we can receive data, we can make sure it's organized correctly, we can make decisions based on it, we can display it. We just got to prove this concept out. We got to show people how it would work, make people comfortable with it, make sure that it aligns with everyone's use cases that might be in the future, and then move forward as we build the system out. So we actually see
Airware is now accepted.
Awesome. So we see 2 accepted flights. They're both co-located, again, just on the airfield out here. And what's going to happen now is NASA has activated. You can see that happen if you want to watch on the GCS side here. Just take a quick update at our manager UI on this side. You can get a lot of quick visual information just by looking over here, seeing an activated flight. The next step, I believe, will be for NASA to get their aircraft in the air. The operator on the sticks right now, Mark Sumich, here at NASA Ames. I believe NASA stays in manual flight for this operation.
And the Airware side is just activated, and now they're streaming data from the aircraft. So they'll probably be going through now and actually launching that aircraft. Looks like they're active, and they just have to take off.
One flight in the air, one getting ready.
Looks like the Airware side is now taking off.
Oh my goodness. 2 drones in the air.
Right next to each other.
Mere dozens of yards apart. Right? Groundbreaking, right guys? So the key is that we know we can do these things safely, right? And we know that we can have a system here that allows both of these operations to happen side by side. You can imagine this being precision agriculture, 2 fields side by side, no big deal, we can do this. 2 cell towers being, being inspected not too far apart, no big deal. I think that's what we're trying to demonstrate here with Build 1.
Yep.
Get people comfortable with that concept.
And you can see on the other side too, you've got 2 active aircraft. The NASA system has clear understanding of where these aircraft are, where they're going, who's flying them, how long they're going to be flying. So a lot of information collected here. It's very simple to kind of see how this can scale out now. And it's not 2, it's 50 or 100 or even 10,000 aircraft.
And again, if anyone wanted to build a public interface to the UTM system, they would be able to pull out these same data, display them in some other way to users and to end users. Someone wanted to have a web portal, for example, that just displayed this information. These track data are available. This plan information will be available. Again, there's some open questions conceptually, like how much of the data do we actually share about each operation with everybody? We do think that there is some level of information that should be shared. And we have to discuss as a community where that cutoff point is, right? We probably don't need the home address of the operator sent out to everybody, right? But we probably just want to know at least what your geofence is, right? And somewhere in between, we need to write that cutoff line of what information is shared about each operation. But seeing it happen here live, we know it can be done. Yep. I'm sorry?
What's that? We couldn't hear.
Why only one
I believe that our current interface right here just allows you to track one flight at a time. That's all. It's just just an implementation issue. Those tracks are available live. If someone wanted to build a better map display to show 800 aircraft at the same time, they would have the ability to do so. On the NASA side, we have focused on getting some initial research done to make sure that a display like this makes sense for this kind of management. But in the future, you can imagine many other kinds of displays do the same kind of work. Some of those might be more consumer facing, for example. These might be more operationally specific. There's a lot of ways this can be done. The NASA flight's landing, we should see it enter a closed state on the manned display.
And the airwear fly will then continue to fly its photo survey. It's on kind of its second to last leg, and then it'll come around, come back in and land as well, and then they'll disarm that aircraft.
NASA has closed out their flight. We see that happen in the manned display. Again, the airwear flight is landing now. Follow-up question?
D7 or plate 7, they wouldn't allow it. In plate 8, they did allow it. What was different between plate 7 and 8? Were they different altitudes?
No. So we're not doing altitude stratification yet in building one. That would be a build 2 concept that we want to look at. What was different is that the second plan that came in, we made sure did not intersect the first plan. In the rejection scenario, we made sure that they did intersect so it would be rejected. That was the difference. The plan, the geofence that was sent in, were made to intersect for the rejection.
Oh, just the intersection.
Yeah, that's all it was. So we rejected the plan outright because we said someone else already has that airspace.
Thank you.
Yep.
So on the airwear side, the aircraft now is coming in. It's coming in to land, and then we'll close out on that side.
One more question over here.
Yeah, we currently have around 90% of U.S. airspace that can be uncontrolled, so we can fly manned VFR aircraft uncontrolled without ever having to contact the FAA or be in touch, do a flight plan or anything. So is your system working on the assumption that all UAS airspace is going to be controlled airspace? And if not, how are you allowing for the UAS aircraft that are not in touch with your system to interact with those that are?
So yeah, we can answer that in a few ways. The word controlled is loaded, right? So if you consider this to be controlled, then yes, right? And we're not actually, when you reserve your airspace, you're able to do whatever you want in there. You don't have to be in contact with our system. Again, this is getting back to that good citizen philosophy that I think Dave Voss was also projecting earlier. We have a feeling most people operating would like to share their information and show that they're active in the system. We understand there's a hobbyist mentality as well. They just want to be able to fly whenever and wherever they want. We do understand that there would probably have to be some negotiation on where that cutoff is, what that interface is between those two things. If that's what you're kind of alluding to, I think.
Well, it's that, and